survey that you have in front of you, you're going to be doing that in the computer lab when we're done going over this exam. I'm going to give you your exam back. The score you have on there is the score before you open your book. I'm going to assume that everybody had good notes and they opened their book and corrected whatever was necessary to be corrected before I gave you the correct answers. So everybody's going to get 100% on the test. But I want you to note that you achieve some pretty high scores not being prepared for a closed book quiz. I think you certainly surprised me. I hope you surprised yourself by having achieved or having been able to answer so many questions correctly. And that's the kind of thing that even near the end of the semester, and then you study a day or two before you have the final exam, you will all pass and get your remote pilot license. So congratulations to everybody for having done so well on what you did not anticipate was a closed book test. But it taught me that you are absorbing the material, and the material that you're absorbing is important for the final exam. There will be many questions of this collection here. There will probably be at least 10 or 15 questions on the final exam from this section. So I think you all did very well. And then we're going to go in and do the survey, and then after we do the survey, we're going to finish off some of your aircraft. Hopefully, try to fly them so that the person that gets the longest flight gets $10. But you don't want $10. No, it's okay. You don't have to. Not here. Not here. Catherine. Andrew. Those of you who got 60 or 65% or above means that you were only 1 or 2 questions away from passing your exam in December, based on the fact that whatever you were able to absorb for this exam, I hope you'll be able to absorb for all the sections. That is, the sections on regulations, on loading and performance, which you just had, on airspace. Okay, so it's important that, sorry. So for all of you, I hope that you continue to study the way you've been studying. Maybe pump it up, but not that much, because if you look at the number of people who scored 65% or higher, it's a pretty significant number. That just means that you're on your way to passing the exam for a remote pilot license. Pardon? Because I want you to see me. Okay, let's go over the exam. And we're going to be going over it not to necessarily correct the answers, because you already know what the correct answer is or are. But I want to go over it because I want you to learn to take these kind of exams. And there are certain clues in the exam that most of you missed. And I want to point those out to you so that when it comes time to take succeeding exams, you will slow down a bit, read the question, see if there are any clues to the right answer. And if there are, then answer it. Okay? Now, number one, dead reckoning, that's that maybe is a term you might, but we talked about it before, and that is you just pick two spots somewhere, run the drone past two spots, time it. If you know the distance between the two spots, you can quickly calculate the speed. Number two, the terrain and structures. Manufacturer's data does not give you terrain because they have no idea where you're going. You might go into the Rocky Mountains, you might go into Florida, you might go into Dinuba. So you should have said to yourself, wait a minute, manufacturer's data is not going to tell me about terrain and altitude of the terrain. That depends on where I go. And the only where I can get that information from is not the road map. Road map doesn't give you terrain, does it? At all. Manufacturer's data certainly doesn't give you terrain. Manufacturer has no idea. You might not even know the manufacturer. The only correct answer was a sectional chart, which you're all familiar with because it has terrain on it. So for you to have missed that meant you probably didn't spend enough time on that question kind of thinking about it. Does it make any sense for the manufacturer to tell me what terrain I'm on? Doesn't to me, huh? Okay, so keep that in mind. These are the kind of clues that are going to make it much better for you to take exams, whether you stop at remote pilot only and put that in your pocket and feel good about it, or whether you go on and become either an aviation maintenance person or a pilot or an air traffic controller. They take the same kind of exams, by the way. They take exams with three possibilities. They're multiple choice, A, B, C. And so the tips that I'm giving you on how to take this exam are the same tips that you're going to use no matter what you do with regard to the FAA. Okay? So let's go to number 3. It's possible, for example, that you could be operating a second one, but is that legal? Operating a second SUS at the same time? No, but certainly it's legal if you put the first one down and operate the second one, right? But the only answer to a good one there is gaining a visual perspective of what 400 feet looks like. So if somebody walks down at the end of the football field and holds up the little hub stand and says, here's what you're going to see at 400 feet, that, to me, is by far the quickest and easiest and most definitive way of being able to determine 400 feet. Okay, number 4, in loading cameras, mount the items in a manner that you can bet that any time FAA talks about mounting or talks about loading or talks about getting at the fact that if you don't do it right, there are going to be adverse consequences. All right? So the only solution for that one that has any adverse consequences is B. It doesn't make any difference whether it's visible to the visual observer. Who cares whether the visual observer can see the camera? He probably can if it's 400 feet high. And who cares if it can be easily removed without the use of tools? The only good answer is the one that the FAA is driving you towards, and that is to stay away from trouble if you're going to be loading equipment on anything, whether it's a drone or an aircraft. Okay, number 5. The pilot's operating handbook does contain, for aircraft, standard weight and balance information. And all aircraft flying, whether they're powered or otherwise, have to have something that says there are weight and balance restrictions. But in this particular case, they were telling you aircraft weight and balance handbook, and they were asking for center of gravity limits, which has to do with weight and balance. So that should have been the clue to drive you to selecting that A. Aeronautical Information Manual, I think all of you would agree that that was a nonsensical solution. That was not anything that had anything to do with weight and balance or center of gravity. So the only two possible ones are aircraft weight and balance in the pilot's operating handbook or the UAS flight manual. But generally speaking, the flight manual for drones doesn't tell you about a weight and balance certificate. As I mentioned that yesterday or the day before, where I looked for weight and balance information on the Hubsan, couldn't find it. I looked for information on the Phantom 4 that you all saw, I couldn't find it. They're assuming that all you're going to do is you're going to hang things right under the center of the drone, no matter how big or how small. Hang things underneath in the center. Okay, so number 6. Now they're talking about consequences, and every time they use the word consequences, you can bet they're talking about something negative, right? Increased maneuverability, is that negative? Faster speed, is that negative? No, neither one of those is negative. But when the consequences of an operating above its maximum allowable weight, what they're saying is, if you go over the maximum allowable weight for your drone or any aircraft, even aircraft we fly, there are negative consequences. And so your answer should be, okay, now which one of those has negative consequences? And the only one that has anything negative is shorter endurance. Okay, number 7, when operating an aircraft, the remote PIC is responsible for using weight data from the factory. That doesn't help you, right? All that says is what the weight of the weight of the drone. It doesn't say anything at all about the weight of the camera of the drone. Unless the drone comes with a camera automatically, but more often than not, the most current weight, because in the meantime, since you got this drone from the factory, you may very well have modified it to carry more weight. So you cannot use the weight and balance data from the factory, and you can't use recent weight. Recent weight and balance could be the last 6 months. So there, the only answer is current, the most current weight and balance data. Okay, and number 8. It talks about weight and balance of what is true of the weight and balance of small unmanned aircraft. The CG cannot change during flight. Of course it can, right? If you decided you were going to drop some... How funny is that, Umberto? Come on. It says the CG cannot change during flight. Of course it can, because if you're going to drop something, it definitely is going to get dropped. And the lateral CG is not important to small unmanned aircraft operations. Of course it is. The lateral CG, because you're going to be maneuvering laterally, right? So in that particular case, the one they're looking for is a negative, and that is if you get outside the weight and balance limitations, you're going to have a problem with control. And number 9, the remote load factor on the wings or rotors may be increased any time. Now, when the gross weight is reduced, no. The load factor is not increasing. If the gross weight is reduced, the load factor goes down, right? Because they're exactly the same. One has an influence on the other. Load factor is determined by the basic load of the drone, and then when you start turning with that drone, you're increasing the load factor. All right, number 10. It says 60 degrees. Okay, I want you guys to remember there are only 2 real good angles, other than the one they had in here, 30 degrees, but that's a lookup. My guess is when you get to the exam, you're either going to be given 60 degrees or 45 degrees. And 60 degrees, you're doubling. The aircraft, the drone feels like it weighs twice its basic weight when it's in a 60-degree bank. And if I could take you all up in an airplane and put you in a 60-degree bank in an airplane, you would feel your body be hard to keep your head straight up, because now your head weighs twice what it would normally weigh. So in that particular case, you go from 10 pounds to 20 pounds. But the fact that they give you a figure to look up means that not only should your common sense prevail, because you'll remember that the maximum they're ever going to give you is 60-degree bank, and that's twice the weight. Or you can make sure when you look it up in the figure 2 that it makes sense to you when you look it up. Okay, number 11. It weighs 50 pounds in a 30-degree bank turn. Now, it's in a bank turn, and it weighs 50 pounds. How could you possibly miss that question? Because if a drone weighs 50 pounds and you put it into a turn, it can't go down to 45 pounds, can it? It can't go down to 10 pounds. The only answer, the only reasonable answer there, the only correct answer, and the only logical answer is that it increased weight. You don't even have to go to figure 2 to look it up. Because the very fact that 2 of the 3 choices are less weight, in spite of the fact that the drone is in a turn, should tell you that the logic, that's definitely a gimme question. There are certain gimme questions on the final exam. Oh, a basic flight maneuver that increases the load factor, it's always going to be a turn. By the way, are you familiar that a stall does not hardly influence an aircraft at all? There's almost no G-forces on an aircraft in a stall. So if you keep that in mind, there's no load factor on an airplane in a stall. Pardon? Is what? Oh, sure. Any aircraft can stall. Any aircraft can stall. And as long as it's traveling through the air, there's an angle of attack. Whether it's a different angle of attack because whether it's a normal angle of attack with a straight. What kind of engine powers an aircraft, whether it's a rocket engine or not, if it has a wing and it has moving through the air, it can stall. And there's a question like that on the private pilot exam. It may not be on the drone, but the answer to the question is an aircraft can stall in any attitude. You know what an attitude is, right? Up, side, up, this way, right? Any attitude, at any airspeed. So you can stall an aircraft at 500 miles an hour, and you can stall it at 60 miles an hour. The speed you're at, if you, by an abrupt movement of the controls, if you exceed critical angle of attack, it'll stall. Keep in mind, dive bombers in the World War II, because they were dropping the bomb straight down, and then they were pulling out too quickly. But by pulling back on the stick, they did the airplane to fly out of the dive, pulled back on the stick, and immediately exceeded the critical angle of attack, and the airplane went in. Followed the bomb right in. Jacob? Okay. Okay, so the angle of attack, everybody should know that by now, right? Relative wind and chord line. Try to keep that in mind. It's the chord line of the wing and the relative wind. It's that angle. An increase in load factor will cause an unmanned aircraft to, the only correct answer is stall at a higher speed. Now, it doesn't make it more difficult to control because you can have a load factor of times. I can control an airplane in a 60-degree bank, but the load factor is going to be twice, right? It's going to be 2.0. But I'm still controlling. So the fact that there's an increase in load factor does not mean that either it has a tendency to spin or it's more difficult to control. But it does mean that the stall speed goes up. And then what effect does an uphill terrain slope have on launch performance? If you're having to fly that drone uphill, it's going to take more distance to get it going. Number 16, the most critical conditions of launch performance are the result of some combination of high gross weight, altitude, temperature, and power plant systems. That's not necessarily critical because you know in advance that you probably have either a high-powered drone or an underpowered drone. Obstacles surrounding the launch site. I hope that you decide not to try to launch your drone between two big rocks. So in this particular case, unfavorable wind is the likely answer. You may not be able to remember that. It may not necessarily be logical to you, but don't worry about it. It may be one of those illogical things that you're just going to have to deal with when it comes time for the exam. Maximum endurance is maintained at the point of maximum power. Maximum endurance. Well, you know it's not going to be in a long-range descent. Maximum endurance means that you're going to be going somewhere a long way and in somewhat level flight, or certainly not in a descent. And at its slowest possible indicated airspeed. So what happens when you get very close to your indicated airspeed? Can you get a maximum endurance out of that? And if not, why not? Does everybody remember the two different kinds of drag? Induced and parasite? And what happens to an aircraft? What happens to the drag when you start slowing way, way, way down and you by raising the nose of the aircraft? That's when you slow way down. You're getting close to the stall, but you're also creating how much? We talked about that before, where there's a bottom to the drag curve, and it's not near the stall, and it's down at a point where the induced drag and the parasite. Right? So you have to remember that with regard to the maximum endurance, it can only be in steady level flight, because in steady level flight you're not using up the battery power as much as you would otherwise. So if you want to go a long way and stay up a long time, don't do any wild maneuvers. Number 18. Again, there was a clue. When range and economy of operation, and one of the answers was long-range cruise performance. The FAA is trying to point out to you, hey guys, the answer is B, because I use range in the answer. And probably that was not accidental. That was probably one of those attempts on the FAA to give you a little bit of maneuvering room to get the answer correctly. Okay, number 19, a UAS loaded with the most rearward center of gravity. Is attaching things to an aircraft with the far most rearward center of gravity, is that a good thing or a bad thing? Huh? That's a bad thing. What you want is to be right in the center of gravity. But now if you've loaded an aircraft or a drone as far back as you can possibly load it, it's not going to be a positive consequence. So in that particular case, it's going to be less stable, because the second and third answers are more stable. That's good. More stable at fast speeds, that's good. So the answer is, if you, the FAA is saying, hey, I'm going to tell you what happens. It's not going to be positive, but if you load that drone at the rearward center of gravity, something bad is going to happen. But it gives you two positive answers against one negative answer. Look at the answers and you ask yourself the question, are they asking me for a positive or a negative? Then read the answers again. I will almost guarantee you that in the answers somewhere you'll see the difference between positive and negative. And that's one of the clues to doing well on exams. Let's see, how many of you are sleeping? There's 1, 2, 3, 4, 5, 6. 6 people. Okay, that's all right. You can go ahead. And in fact, to prevent you from snoring, it's best to go back in the back of the room. Go to sleep on one of those desks back there. The purpose of the rudder performance on an SUAS airplane, rudder controls what? By now, everybody should know that it controls yaw, correctly? Yaw, rudder, yaw, no? All right, well, then you're going to have to memorize that. In a 45-degree banking turn, a UA will stall at a higher airspeed. There's nothing that says it's susceptible to spinning. By the way, do you know how conditions necessary for a spin? Pardon? Not necessarily. The one clue to a spin, whether it's a drone or an aircraft, is it has to be very, very close to the stall. So when I spin an airplane for my students, I have to get all the way down to the point where it's just about to stall, and what I do is I kick one of the rudders to the left if I want to spin left, or I'll kick right if I want to spin right. I cannot spin an airplane if we're not slow enough. If we're not near the stall, I can't spin. right? But I can stall, can I? Stall at any airspeed and any attitude? Right, but I can't spin. And again, a spin is nothing more than a nice lazy turn that has no g-forces on it. Keeps rotating down, 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 right? So, in that particular one, you have to say to yourself, what is the positive answer or the negative answer? Are they looking for a positive answer or a negative answer? Now, as soon as you get into a 45-degree bank, they're probably going to ask you for something negative, right? Otherwise, it was straight and level. There's nothing really negative about straight and level. But the minute they introduce the word turn in some fashion, no matter what degree it is, they're looking for something not positive. Okay, number 22 and last. What's the best source for data and information? Pilot reports have no relevance. Pilot reports are things that if I'm going to be flying over the Gorman Pass, I'm hoping that somebody ahead of me has experienced or has not experienced any turbulence, but if they have, I would hope that they would radio on 122.0 and tell the briefer at that point in time that he was experiencing anything from light chop to moderate to severe turbulence. Those are pilot reports. And when you see pilot reports on TAMs or on information to you, it'll always tell you the type of aircraft, and it'll tell you the reason it's a type of aircraft is because turbulence, moderate turbulence in a Boeing 727 is going to be severe turbulence in a little Piper Cherokee. So they always will specify the type of aircraft. And especially if you report Boeing 787 is going to yawn because they know it's coming from a little Cherokee that's going to get all over the place. So estimates based upon similar systems, that's no good because you can't define what a similar system is, right? So the very fact that they introduced that answer, similar system, red flag for you that now they're asking me for a similar. I have no idea what similar means, therefore that answer is incorrect because they don't specify clearly enough what similar means. So these kind of things that you'll encounter in all the next kind of questions that we're going to have on that you're going to spend some time looking over the questions carefully. A couple of hours for a 60 question. A 2 full question. Generally speaking, some of the questions that are automatically going 15 seconds. That means you'll have another minute. So now you're going to have 3.5, maybe 4 minutes for another question. Just remember, look at them carefully and don't take a lot of time. Don't assume that you automatically know the answer because you have to very clearly say to yourself, am I looking at the questions and the answers properly? So it's looking for if I get a negative question, they're looking for a negative answer. If I get a positive question, they're looking for a positive answer. So your very first filter should be positive or negative question and answer. Okay, so now you have this on here. You have to, for the survey, you have to do it for both courses. You have to do it for ground school as well as you have to do it for history of aviation. History of aviation is period 6. The ground school is period 7. Those instructions there should be clear enough, but I'll be with you in the computer lab to make sure that you follow the instructions carefully. What the people in Sanger are looking for are honest answers. Not the answers that I want to see, not the answers that they want to see. They only want answers that you believe to be the true answer that you're willing to put down in paper. I'm not going to see anything. I don't see the results. They go to Sanger, and then Sanger may or may not give me the results in a summary form. They won't give me individual records. So what you put in there for yourself is going to be information that is confidential. Okay, let's go ahead and go into the computer lab. Take your cheat sheet with you so you know how to do it.